Hello everybody and welcome back to another visual pattern challenge. Here's our pattern today. Here's step 1, here's step 2, here's step 3, and your challenge is to figure out how many of these little, I'm going to call them berries, how many berries, these little dots on the end of the twigs, are in step 4. If you can do that, can you predict how many would be in step 43? And could you write an equation that could be used to tell the number of berries in any step at all? So that's the challenge. If you'd like to accept it, pause the video and see what you can do. All right, so this is kind of an interesting one. We have these branches or twigs and these little berries on the ends. And let's see, first we have a twig and it splits into 2 twigs and there's a berry on the end of each twig. And then it looks like those two twigs split into 2 more twigs. And there are berries on each of those. Yeah, and then those 4 twigs split into 2 twigs each, and then we have berries on the ends of those. So if I were going to predict step 4, I'd say we'd have, all of these twigs splitting into 2 again, and then berries on the ends of each of those. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I think we'll have 16 berries in step 4. Now, we have looked at patterns something like this before, although not in this particular shape. So maybe you know what's going on already, but let's go ahead and just analyze the numbers that we have and see if we can make any sense of this from the numbers. So I'm going to put in a chart the step number and the number of berries. So in step 1, we've got 2 berries. In step 2, we've got 4. In step 3, that's 8. And we're predicting 16 for step 4. And usually when we're analyzing these patterns, we take the differences. So 4 minus 2 is 2, 8 minus 4 is 4, 16 minus 8 is 8. We did not get a constant, so you might be tempted to take the difference of the differences, see if you get a constant there. And 4 minus 2 is 2, and 8 minus 4 is 4. And you might start to see a repeating pattern. We had, for our numbers, 2, 4, 8, 16. And then for our first set of differences, 2, 4, 8. And the next 2, 4. This would go on and on like this. So we would never find a constant here. When you see a pattern like that, it's because this is an exponential pattern. So there's some number to a power, and the power is the variable. The power represents the step number. In an exponential function, to figure out what that base is, what the number is that you're raising to a power, you look at how much it's increasing in each step. Is it doubling, tripling, quadrupling, etc.? And in this pattern, I think we're doubling, right? Because you're splitting into 2 each time. So 2 becomes 4 and 4 becomes 8. So we're doubling between each step. And what that means is this pattern has 2 to the x. And sometimes in patterns like this, there's other stuff. There might be a number to multiply by, and there might be something else. In this case, I think that's it, because if we put 2 to the first power here, that's 2. If we put 2 to the second power for step 2, that's 4. 2 to the third power in step 3 is 8. That's exactly how many berries we have. So our equation is simply 2 to the x power, to the step number power. Once you've got that, figuring out step 43 isn't too difficult, at least if you have a calculator. So we would say y equals 2 to the 43rd power. And when I punch that into mine, I'm getting 8,796,000,000,000 93,022,208. So that's how many berries in step 43. Well, how did that go for you? Did you see that step 4 was going to be 16? Were you able to see that this was an exponential equation? It's pretty tricky. Let me know. Thanks, everybody.